Let us do a very simple sum. It is a very interesting one, a very easy one. Right? Let's see the sum. It says that, are the triangles in the figure similar? If yes, by which test? Now, if you see, by looking at it, we'll know that one of the tests which we need to apply to prove them similar is going to be SSS test. It has to be that test because information is only about the sides. But let's check for that. Are the ratios equal? But how do we take the ratios? Because we don't know which side is corresponding to which one. Easy, you remember. How do we do it? Yes, take the smallest side here. Which is the smallest side in triangle PQR? It is PQ. And which is the smallest side here? The smallest side is LM. So take the ratio of PQ and LM. So we get PQ upon LM is equal to 6 upon 3. And that when you cancel it is 3 ones are, 3 twos are. That means you get 2 upon 1. And that's the result number 1. Easy. Now, smallest is done. Now we take the largest, right? The largest here is PR and the largest there is LN. That means we write here PR upon LN is equal to 10 upon 5. It is 5 ones or 5 twos are. So you get the ratio as 2 upon 1 and that's our result number 2. Now you know which one to take. Smallest is done, largest is done, the remaining one, which one is that? QR, and the remaining one here is MN. So we take QR upon MN, that is 8 upon 4, and that is nothing but 4 ones are, 4 twos are, so we get ratio as 2 upon 1, and that's our result number 3. So in both the triangles, we know all the 3 ratios are equal. So we write there in both the triangles, we get PQ upon LM is equal to PR upon LN is equal to QR upon MN. All the 3 ratios are equal. From where did we get that? From 1, 2 and 3. Now we wrote this, but we know now both the triangles are going to be similar. Write the name of one triangle. We wrote that as PQR. But we don't know the name of the other triangle. That is not known to us. How do we write that? For that, yes, there are 2 ways of writing it. One, we have already learned, take any 2 ratios. Right? There's one more way of doing it. Right, what you do is pick up the first ratio. In the first ratio, look at the numerator PQ. PQ is the side opposite to which angle, right? Opposite angle is going to be R, right? Because it's very simple. The triangle is PQR. So once we take PQ, the opposite is nothing but the remaining vertex, isn't it? So simple. The same way, when you take LM, LM is the side opposite to which one? It is opposite to angle N. So we write there angle N. So now we know R corresponds to N. So we write R corresponds to N, right? Same way, take the next one here, QR. QR is opposite to angle P. So, right, so now we are going to write the corresponding side of P, right? Corresponding vertex of P. Now look here, MN, opposite to which one? Opposite to angle L, right? So that means we know that P corresponds to L. And now the remaining one we know in this triangle LMN, L we have written, N we have written. So what is remaining? M. So we write that M. And now we know that triangle PQR is similar to triangle LMN, and both angles are similar to each other by SSS test of similarity. That's the other way of writing it. Easy.